For 4.5 billion years, it has been the constant in our sky, a radiant sphere of fire and light that has forged worlds and seeded life. We call it the sun. It is the heart of our solar system, the reason we exist. It warms our oceans, nourishes our plants, and bathes our planet in the life-giving energy that makes our blue marble a haven in the cold, dark expanse of space. We look up at it every day, so reliably present that we often forget a simple, terrifying truth. The sun is a star, and like all stars, it is mortal. It is not an eternal flame. It has a beginning, a middle, and an inevitable end. And when that end comes, it will not be a sudden, spectacular bang, but a slow, creeping apocalypse that will consume everything it once created. Hello, welcome to Astronomical Library. This is not a question of if, but when. In this journey, we will travel far into the future, far beyond the lifespan of any civilization, to a time when our sun, the very source of our existence, begins to die. We will witness the slow, agonizing demise of our star and the chilling, final fate of our planet. The end of our world won't be a fictional cataclysm from a Hollywood movie. It will be a scientific certainty, a cosmic tragedy on a scale we can barely imagine. This is the story of our final day, billions of years from now. Our story begins in the present day, with the sun as we know it. From our perspective, it is a stable, reliable source of light and warmth, a perfect example of a main sequence star. At this stage of its life, the sun is powered by nuclear fusion in its core, where immense pressure and temperatures around 15 million degrees Celsius force hydrogen atoms to fuse into helium. This process, which releases a tremendous amount of energy, has been the engine of our solar system for billions of years. For all of its power, the sun is a remarkably balanced system. The outward pressure from the fusion in its core is perfectly balanced by the inward pull of its own immense gravity. This delicate equilibrium is what has kept our star stable and shining so brightly. But this balance is a temporary one. The sun's hydrogen fuel is not infinite. Roughly 600 million tons of hydrogen are converted into helium every second. Over the last 4.5 billion years, about half of the hydrogen in the sun's core has been consumed. In another 5 billion years, that fuel will be exhausted. This event will trigger the first of a series of catastrophic changes that will spell the end for our planet. As the sun's core runs out of hydrogen, the fusion reactions there will begin to slow down and eventually stop. Without the outward pressure from fusion, the core will start to collapse under the crushing weight of the sun's own gravity. This collapse will generate an enormous amount of heat, causing a shell of hydrogen just outside the core to ignite and begin its own fusion. The energy from this new fusion shell will be so intense that it will push the sun's outer layers outward, causing the star to swell to a massive size. This is the beginning of the end. The first signs of this coming apocalypse will be felt on Earth long before the sun becomes a red giant. In approximately 1 billion years, the sun will be about 10% brighter and 10% hotter than it is today. This seemingly small increase will have a devastating impact on our planet. The rising temperature will trigger a runaway greenhouse effect, causing Earth's oceans to begin to boil. The water vapor will fill the atmosphere, trapping even more heat. The planet will become a scorching, uninhabitable wasteland. The last traces of complex life, the animals, the plants, the ecosystems we know and love have already vanished. For any humans or descendants of humans who may still exist, they will have had to find a new home far away from Earth, a cosmic refugee crisis on an unimaginable scale. The sun's expansion will continue for another several billion years. As it gradually becomes what is known as a subgiant star, its outer atmosphere will cool and redden, and it will swell to a size that will dwarf its current self. This is when the true horror begins. As the sun transitions into a subgiant star, the changes we've already discussed are just the beginning of a truly horrifying cosmic event. Over the next several 100 million years, the sun's outer layers will expand and cool dramatically, transforming it into a full-fledged red giant. At its peak, the sun's radius will increase so much that it will likely engulf Mercury and Venus completely, incinerating both planets and absorbing their matter into its bloated, cooler outer atmosphere. From a safe distance, this new red giant sun will be a terrifying spectacle. It will fill a significant portion of our sky, its familiar yellow hue replaced by a fiery blood-red glow. The intense radiation and gravitational forces from its swollen form will strip away any remaining atmosphere from our planet. The very ground we stand on will become a sea of molten rock. The oceans, long since boiled away, will be a distant memory. This is the ultimate heat death, a planetary cremation on a scale we can barely comprehend. The final, definitive moment for Earth is a subject of ongoing scientific debate. Some models suggest that Earth's orbit will be widened and pushed outward by the sun's mass loss, allowing our planet to escape being swallowed. However, other, more widely accepted theories posit that the red giant sun's expanded outer atmosphere will still be dense enough to create significant drag on Earth's orbit. This atmospheric friction would act as a braking mechanism, causing our planet to spiral inward and plunge directly into the sun. In either scenario, the outcome is the same: the complete annihilation of our world, leaving no trace of the life that once thrived here. But the death of the red giant is not the end of the cosmic spectacle. Even this destructive, monstrous phase is temporary. The red giant phase is fueled by the fusion of helium into carbon in its core, a process that is far less efficient than burning hydrogen. Eventually, after about 1 billion years of a red giant's life, the helium fuel will also be exhausted. The red giant will then become unstable, violently shedding its outer layers into space. This massive expulsion of gas and dust will create a breathtaking, ethereal cloud known as a planetary nebula. For a brief cosmic moment, only tens of thousands of years, this nebula will glow with an otherworldly beauty, illuminated by the dying ember at its center. This ember is the sun's former core, now a small, incredibly dense, and intensely hot object called a white dwarf. The white dwarf is the final silent tomb of our once mighty star. No longer generating energy through fusion, it is simply a remnant of carbon and oxygen, a star that has died but is not yet cold. It will continue to shine with residual heat for trillions of years, a ghostly lantern in the dark, before it eventually cools down completely to become a black dwarf, invisible, cold, and utterly dead celestial body. The solar system, once a vibrant collection of life and light, will be a graveyard of frozen planets, a vast, dark expanse orbiting a single, invisible tomb. So, with our home gone, does this mean the end of humanity? Not necessarily. Our story so far has been one of celestial certainties and inevitable cosmic events. But our future is not sealed by the stars alone. Long before the sun's final death throes, humanity would have faced a choice: adapt, or become another entry in the universe's endless list of extinct species. The final chapters of our story would be written not on Earth, but in the stars themselves. As the sun brightens over the next billion years, humanity's only hope for survival would be to leave Earth. The moons of Jupiter and Saturn, like Titan and Enceladus, would become new havens. Once frozen, these distant worlds would be warmed by the swelling sun, their buried oceans melting into vast new seas. This would be a new age of exploration and colonization, a desperate but resilient effort to find a new home in the outer solar system. But even these new homes would be temporary. As the sun enters its red giant phase, its immense power would eventually make even the outer solar system uninhabitable. Our only remaining option would be to leave the solar system entirely. We would need to become a true interstellar species, a civilization capable of building arc ships to travel to distant star systems. We would carry with us not just the memories of Earth, but the very essence of human resilience, a testament to our will to survive. Our sun's death is a chilling reminder of the fragility of our existence, but it is also a powerful driver for our ambition. It forces us to look beyond our own planet and consider what it truly means to be a species with a future. The journey through the end of our solar system is a humbling one. It teaches us that our home, our source of life, is not eternal. The end of Earth is not a matter of if, but when, a scientific certainty sealed by the laws of physics. The oceans will boil, the mountains will melt, and the ground we walk on will be consumed by a dying star. But perhaps the story of humanity is not tied to the destiny of a single planet or a single star. Perhaps our true legacy will be written in our ability to adapt, to explore, and to carry the flame of life to new homes across the vastness of the cosmos. The sun may die, but the spirit of humanity, born from its light, might find a way to live on. When faced with the inevitable end of our home, what do you think is the most important thing for humanity to do today? The death of our sun is an undeniable truth, but the story of humanity is far from over. When faced with this reality, what do you think is the most important thing for us to do today? What steps should we take to ensure our survival? Share your thoughts in the comments below, and don't forget to like this video and subscribe to the channel to keep exploring the universe's other mysteries with us.